In this video, we'll learn about dilations. So, a simple way to look at a dilation is either an enlargement or a reduction. For example, zoom in versus zoom out that you use frequently on your Photos app. So, maybe something's this small and we want to make it this big. So there's a relationship between the corresponding sides. So let's say if this is 3 and it suddenly becomes 9, and this is 4 and it becomes 12. So look at the ratio of the sides. So the ratio of the sides tells us that let's color this blue. The blue shape is 3 times as big as the red shape. So that's what a dilation is all about. So what we'll do is we'll try to look for corresponding lengths and see if it's reduced or if it's increased. Now, if it's reduced, then the dilation will be a fraction, so 1/3. But if it's enlarged, then it will be a multiple, bigger than 1, right? So it's bigger. So 2.5 times is allowed. That will obviously be a dilation which is bigger. So let's try a few axes. Okay, so we've got this. Write the coordinates of the vertices after a dilation with a scale factor of 1/4, centered at the origin. So one easy way to do this question is to take all the points and multiply it by the scale factor, which is 1/4 in this case. So if I multiply everything by 1/4, this will become -2. This will become 2. This will become -1, and this will become 2. And then this will become -2 and -2. And then I get my first answer. Okay, let's try this. Write the coordinates of the vertices after a dilation with a scale factor of half, centered at the origin. So again, same type of question, but scale factor is half, so we'll multiply everything by a half. So we get -5, -1, 3, -1, 3, 1, and then we have -2, and we have 1. Okay, let's try this. So the orange shape is a dilation of the black shape. So what's happening over here? The shape is being reduced. So the black one's the original, and the orange is the new shape. So it's being reduced, so reduction. Let's try this. The purple shape is a dilation of the black shape. What is the scale factor? So here, these are 3, and even these are 3. And then they become 1 and 1. So the purple shape over the black shape. So the purple is 1, the black is 3. So we want the shape at the end as our image. So let's put in our answer as a fraction, 1/3, and hit submit, and that's how we get a correct answer. Let's try this one. So graph the image of rectangle JKLM after a dilation with scale factor of 2, centered at the origin. So everything gets multiplied by 2 is what's happening. So if I have a coordinate Like let's look at k, that is 5 and negative 2. So I'm going to multiply everything by 2. So that will become 10 and negative 4. So this is where it's going to end up. All right. And same with L. This is 5 and 3. So that will become 10 and 6. So this is L, right? So we've got to graph it. So let's put these points. So let's put this point, let's put this point. And then this one becomes negative 5 and 3, which becomes negative 10 and 6. So here, okay. So this, what is happening is that it wants me to go in the order. So J will become negative 5 and negative 2. Sorry. So that will become negative 10 and negative 4. So right here, and this will become 10 and 6. And that's how I get my image. So I doubled everything. Okay, let's try this, and then you guys can try a few questions. So the blue shape is a dilation of the black shape. Is it an enlargement or a reduction? So again, blue shape comes out of the black shape. So is it being enlarged? Yes, indeed. So you guys can try a few things over here. Either multiply by the scale factor or see if it's being enlarged or reduced. Good luck.